Good morning, everyone. Today, we are going to discuss aerial electroculture antennas. This technique utilizes aerial antennas based on historical research and records, particularly from the French National Digital Library, Gallica. Through historical installations, it has been observed that ambient electromagnetism can interact with crops, plants, and improve growth, germination, as well as resistance to plant diseases. This presentation will delve into this technique, its history, and its potential applications, such as in vegetable gardens, orchards, or vineyards for energizing water. Although these methods may seem unconventional or even eccentric, this video aims to shed light on the origins of this technique, as well as provide guidance on how to implement it in your own space for experimentation. Information shared in this video is derived from a recent book on aerial and magnetic themes, offering insights into historical practices and practical applications. Exploring techniques from the Enlightenment era when electricity was discovered, experiments on plants began to reveal their responsiveness to electricity. For instance, experiments like Faraday's with Faraday cages demonstrated how plants reacted when shielded from ambient electromagnetic radiation. This observation led to the understanding of the connection between electromagnetism and plant life. Inspired by these findings, I constructed a large antenna in my garden last year to conduct experiments and measure natural currents. Additionally, a document over 100 years old shows similar installations in fields, known for their efficacy during wartime. Through experiments, the aim is to boost growth, germination, and plant disease resistance. Electroculture, as a field, continues to offer intriguing possibilities for enhancing agricultural practices. The subject of electroculture is vast and has been extensively researched. In the book Electroculture and Free Energy by Maxence Leylat and Roland Verlaine, it is mentioned that between 1745 and 1910, more than 450 researchers delved into this field. France was a pioneer in electroculture, aiming to create systems that capture electromagnetic waves from natural ambient magnetic fields to interact with plants. There are two types of electroculture: active electroculture, where current is sent to plants, and passive electroculture, where a simple metal antenna is planted in the ground to interact with natural electrons, promoting plant growth without artificial electricity. In the active electroculture method, power is sent over the culture, resembling electric rivers that enhance production. On the other hand, passive electroculture relies on natural ambient electromagnetism to interact with plants and stimulate their growth and development. An example of active electroculture can be seen in the Belleville garden in Paris, where electric rivers interacted with plants to increase production. In the Encyclopedia of Science and Labor from 1926, a depiction of active electroculture in Belleville, Paris, showcases the method of using electric rivers to enhance plant growth. The focus of the video is on passive electroculture, which interacts with natural ambient electromagnetism to promote plant growth. Historical texts, such as the writings of Abbé Bertholin from the 1700s, discuss the electrical properties of plants, their effects, and the application of electricity to agriculture. Abbé Bertholin's experiments, including the invention of an electrovegetectometer, demonstrate the utilization of natural electricity in agriculture. Electromagnetism, and plants are now seen on a wooden pontoon with a unique pipette connected to a tank at the back. The tank is filled with electrified water that is being sent through the pipette to the plants on the pontoon. This electrified water, similar to storm water, carries a more electrifying charge than conventional water, which is believed to be beneficial for the plants. This experiment links us to the connection between electricity and water. In modern times, experiments are conducted using passive electroculture to energize water and enhance the growth of plants, resulting in more vigorous seedlings. Historical documents from l'Abbé Bertholin reveal the use of antennas in early systems that utilized spikes to connect with the atmosphere and the ground. The Bekensteiner antenna, for instance, had a bouquet of metallic tips connecting with the atmosphere and a common thread connecting to the ground to promote electron exchanges, for natural yield factors. Brother Paulin, the director of the School of Agriculture in Beauvais, extensively researched electroculture around 1896. He developed the geomagnetic R and implemented passive electroculture antennas in fields, reaching heights of 12 to 20 meters with wire systems buried 25 meters apart. While burying wires in fields is no longer a common practice today, these historical examples provide insights for current agricultural practices. Days, reapply this in our context. For example, if we consider life, the wire is already present. There is more in quotation marks than adding the antenna and the connections. Now, we see Brother Paulin who had developed these techniques that he used in the fields. We see the donkey just next door where the ox, which is very small. Let's consider the size of these installations. They were there, a bit as if to imitate trees which have a root and aerial system which will also interact electromagnetically with cultures. We find a lot of death period documents still on the Bibliothèque Nationale de France Gallica with writings on how these systems were created. Then historical reports show exceptional results. The harvests are bigger naturally without chemical fertilizer. What do we see? We always have this antenna that rises 12 to 20 meters above the water. At the top, there are wires made of copper, a porcelain head to insulate the head. A conductor made of wood descends from the wooden mast, which is 12 to 20 meters high. From the top conducting head, copper descends a galvanized wire that is insulated from the mast with porcelain insulators. This is connected to the metal structure in the ground, which is in contact with the root scalp and root hair. It's great to realize the drawing of the time. You see with the mill there, the mill that makes us think that before in France there were mills everywhere. Unfortunately we think that maybe these systems were also developed in Africa. Because here we have a drawing that could be a hypothesis that could make us think of types of African habitats. In any case, it's a drawing that's over 100 years old where there is also the geomagnetic made inside. I have more details, but I'm not going to read them because it would be too long and maybe boring. I invite you to pause and look. You have the descriptions of these systems and, above all, here are some feedback from the time when it was said that planting these metal antennae in the ground and then leaving them to function passively was too technical. We see reports with complete details of successes achieved with the geomagnetic field. It was noted that exceptional results were obtained with potatoes that are more productive, and vines in better health and more productive. There were potato stems reported to grow up to 2 meters and 45 centimeters. That's what you actually read when you look into it. The electroculture of historical documents often yields incredible results. When we first start experimenting, we also notice changes in our garden. For instance, I recently recolorized a document from around 1910 featuring Colonel Fernand Bastique. This document, which can also be found on Gallica, showcases his garden where he experimented with electroculture systems. In the document, we can observe different areas highlighted in blue and red. The blue areas represent where electroculture systems were implemented, showing that vegetation germinated earlier compared to areas without a system. We can see that plants grew larger, healthier, and had accelerated germination in these areas. Historical writings, such as those available on Gallica, reveal that France was a pioneer in electroculture and later exported these techniques internationally. The first International Electroculture Congress took place over 100 years ago in 1912 in Reims, where Colonel Fernand Bastique was in attendance. More recent writings, like a 1975 newspaper article, discussed the cultivation of plants using electric fluid. After World War II, Electroculture nearly disappeared from dictionaries and encyclopedias, falling into obscurity. Thanks to the internet, old documents are resurfacing, allowing us to revisit and experiment with ecological techniques that avoid chemical fertilizers and align with natural principles. Growth, germination, and resistance of plants. So, what do we see with the famous antenna? Electroculture involves using electric fluids. It consists of a pole, a hand-like structure with spikes, metallic at the top. An interesting feature is a track with a wire placed in a circular shape, seemingly to interact with magnetism, for example, terrestrial magnetic coils. This antenna, which I came across in a magazine, is quite atypical. It is also mentioned in this document, highlighting exceptional harvests. Dart. Imagine lettuces with a 1-meter circumference, leeks as big as one's forearm, and wild strawberries transplanted at the base of the antenna growing as big as nuts. These remarkable harvests and discoveries may seem extraordinary and almost unbelievable at first glance. However, as we delve deeper, we come to learn about Justin-Étienne Christofleau, a pioneer of electroculture in the 20th century. He was very active in the field from 1905 to 1939, filing between 1 to 5 patents per year. Christofleau was instrumental in the development of electroculture, even inventing a machine for making electric bread. Through his work, he focused on increasing crop yields and reviving diseased trees without relying on chemical fertilizers. His techniques harnessed natural ambient electromagnetism, eliminating the need for yearly purchases of consumables and promoting a natural, renewable agricultural system. Christofleau's dedication to sustainable agriculture earned him recognition, being decorated as a Knight of the Order of Merit Agricole, and a member of the Société des Inventeurs de France. In the period documents, we see him with his electroculture antenna, a technology he later exported internationally to countries like Australia and China. In a photo, he is depicted at his desk with the electroculture antenna he developed, which gained popularity abroad. His book on electroculture was found in the Parliamente bookstore in Canberra, Australia. A 1927 document, colorized as a tribute, showcases his contributions to the field. China to Justin Christopher Mr. He was apparently going to distribute millions of copies of these devices around the world. Can we read another document while waiting in line in Les Yvelines where he lived? We see a rye 2 meters high, and are told we are in Gulliver's Garden. If you read the article from the time, you will also discover extraordinary things in this document. How did he do it? He had aerial antenna systems placed at the top of the hands, as seen in this English document. We discussed the incredible discovery of the new French magician and his aerial antenna, which he erected to over 25 meters high on top of a pole. Then, the antenna is connected to a tree to interact with it. This revolution in agriculture is often mentioned in ancient writings as a significant development. Now we have his electroculture antenna, priced at 70 francs, which eliminates the need for fertilizer and manure. There are numerous official certificates of the results obtained in 13 French departments in Alsace-Lorraine and conclusions by agronomic stations. When looking for historical documents, there is a plethora of information to understand and observe to refine techniques for more efficient results. There are still techniques to learn, understand, and develop further. We can see his antenna from the magazine Rustica of the time with its electroculture antenna that reached a minimum height of 650 meters. There are various parts to observe. At first glance, it may seem a bit strange, but it was designed thoughtfully. At the top, there are many spikes to connect with the atmosphere and promote the exchange of electrons between air and soil. Some of the spikes are flexible and move in the wind, creating friction and facilitating electron movement. There is a flat part with notches to capture electrons from water droplets, as water is also electrically charged. When it falls on the antenna, there is an interaction. Electrons that can be brought closer to its drops come via this part. We have a kind of natural battery that is created in the case with differences in metals, like copper and zinc, for example, to make a kind of voltaic battery. The action of the sun is also taken into account with, for example, the small kind of tube with wings on the sides. What we observe is that with parts in the shade and parts in the sun, it also creates temperature differences which apparently could promote electrical exchanges. Finally, what we observe is a tip in materials that are ferromagnetic and can magnetize and interact with the Earth's natural magnetic field. I am sending you back the video I made on magnets and magnetism, where I talk a bit about this antenna that interacts with different weather conditions, disturbances, electromagnetic changes, electrical variations in the atmosphere or the ground. The bolt on the right of the housing will allow you to connect an iron wire to galvanize it. This galvanized wire will be connected to a tree in our plot of land. I am showing you one of the antennae that I built with my former electrician neighbors. We have a radiator that I bought at Emmaus, which is there to capture the electrons from raindrops based on the work of Alandir. Aerial antenna systems come in different types and designs, and there were many developed historically. France was a pioneer in this technology, which was later exported internationally. There were various antenna systems, including one found in a Russian document, resembling the one I showed you earlier. An experimental farm in the United States in Iowa also featured various antennas, including that of Christofleau. He placed his antennas at the top of my hand for field experiments. In fact, they connect to the crops and put them on at regular intervals to interact with the plants. In a photo from the 1930s, you can see an experimental farm in the United States in the years 1930, 1931, and 1932. So, I spent tens and dozens of hours searching through the French National Digital Library Gallica, and in 95% of cases, the results were positive. However, in some cases we found out that it did not work, possibly due to drought conditions during those years. It is worth mentioning that this is one of the last historical documents available before moving on to discussing how it works. If you want to experiment at home, we have a document from 1978 from Rustica magazine, which is one of the most recent sources from the end of the 20th century. In this document, we see the new green saucers electrifying the vegetable garden, which may seem intimidating, but it operates on current parameters and is passive once set up, working with ambient electromagnetism. Before moving on, let's discuss how it works and how to test it at your home. A quick reminder that there are plenty of images and videos on permaculture, related to this topic in the article tab, which can assist you in your research. Additionally, the book Electroculture by Justin Etienne Christopher, in English, is available for free on the site, providing valuable information. There is substantial documentation available, especially on the French National Digital Library, Gallica. Now, how does this system actually work? How can we understand and implement these techniques at home in our vegetable garden, vineyard, or when dynamizing water? There are a few key notions to grasp, which I will simplify for you. Imagine an atom. If we zoom in on living things, breaking it down into cells, molecules, and atoms, we reach the atomic level. By delving deeper into the quantum level, we can better understand how this system operates. In the nucleus, there are positively charged protons, while negatively charged electrons circulate around the nucleus. This diagram simplifies the concept. It's important to remember that at the center, we have positive charges from protons, and electrons revolving around the nucleus are negatively charged. This balance of charges is essential to understanding atoms. For instance, an atom with 3 positive charges and 3 negative charges is neutral. 3 plus 3 equals 0. If we introduce another atom with the same charge balance, the overall charge remains neutral. However, when electrons transfer between atoms, the charges change. For example, when an electron moves from one atom to another, the donating atom becomes positively charged, while the receiving atom becomes negatively charged. This illustrates how electron transfers occur in nature, creating positive and negative charges. This phenomenon can be observed in the environment, where the ground is negatively charged compared to the air, which is positively charged. This difference in charge distribution results in electrical exchanges, with the Earth acting as a vast reservoir of negative charges and the atmosphere holding positive charges. These exchanges occur naturally, facilitated by phenomena like lightning, where electrons move between the ground and the atmosphere. Antennas play a role in promoting these exchanges, and facilitating the movement of electrons between the ground and the atmosphere. These exchanges, and now I zoomed in. You see, we have my antenna, and we can see that it has spikes. I am zooming in on one of the spikes. To understand this phenomenon in a little more detail, we have the electrons that go up through the tip. What happens is we have these positive electrical charges globally in the air. Well, what happens is that opposites attract. So, you have electrons that will go to the positive charge and recharge its charges. This will sometimes make them become neutral again. We have the charges of the electrons that go up like that, and then they will go and connect to the positive charges, and that's when electron transfers happen. With the movements of air mass, in fact, there is the air that will have mass movements like that, and molecules in the air, they will move, and so our antennae will be in connection with certain atoms or molecules, and this will allow these famous electron exchanges. This image allows you to better visualize how it happens in nature, and when you plant an antenna, how electron transfers really occur. I'm sorry, it's a bit technical, but I'm trying to explain it as clearly as possible to help you understand and move away from subjectivity a bit. To better understand all this, let's see a concrete example. So, I thank Galaxy for his photo. What are we observing, Alexis? He put lots of antennae in his garden, in fact. So, compare a space to a naked one. It's really not the same if you have a bare space or a space with antennas, because they promote the exchange of electrons that you see between the top of the antennae and the bottom of the ground. We can clearly see that if she was not there, these antennas, there would not be a high enough connection with the atmosphere like antennae do. And then, furthermore, you see here, it's a photo that was shared with us. So, thank you for sharing this photo in the Facebook group Electroculture and Permaculture. I think it's Francois. Thank you. And now we see a brush, a northern finch, that he took a photo of that landed on his antenna. So, you should know that insects and birds, well, when they fly, they discharge electrons. And when it lands on the antenna, what happens is there is a small electrical impulse, like sometimes when we touch each other and we get a little shock. Now, that's what happens. There is a difference in electrical potential between the bird and the antenna charge. In fact, the bird will pump electrons to the antenna every time it lands. It takes electrons, and its electrons come from the ground. Something that will give us another vision of the garden, where every time the birds land, they will stimulate electron exchanges. This interaction will also affect plants, especially since having birds in our house brings joy through their singing, which is known to stimulate both plants and provide nutrient-rich droppings rich in phosphorus. Phosphorus is beneficial for plant fertility, both physically and energetically. By connecting vibratory and electronic angles through electron exchanges, we can enhance the environment. As electrons are diffused in the atmosphere, walking in forests, rich in antioxidants, can be beneficial for the body. Additionally, an electroosmosis effect can occur, allowing water from the basement to rise higher if our antennae are connected to the humid part. Historical documents, like the Bunkensteiner document from 1892 or 1882, mention using antennas to harness lightning strikes for agricultural purposes, demonstrating a bioelectronic modification of the environment. Vincent Bioelectronics offers insights into health and fertility from a biological and electronic perspective, including pH and ORP considerations. Utilizing electroculture antennas can provide plants with additional electrons, promoting their well-being. For instance, a sound antenna system placed strategically on the south side of a vine row, aligned with the Earth's natural magnetic field, can magnetize the plant and enhance its growth. Experimenting with vine orientation, such as north-south alignment, can yield humanistic effects when placing antennas accordingly. By strategically situating antennas in the vineyard, we can leverage the natural magnetic field, showcasing how environmental modifications can positively impact plant growth and health. With copper wire, there will be effects because of more natural electron exchanges. It doesn't really have to be oriented north-south or this technique, aerial antennas. Based on what I am reading, you see, you have an example. Thank you. So we have Yann from the company of Saffron and Vines who testified in the book In an Aerial to Magnetic that I released, where he tested in previous years this antenna technique on another part of the vine, and he saw positive results. So now he made a bigger antenna that goes up to 8 meters. He tells me it seems, and with a quartz crystal settled at the top. Why am I telling you that the antenna can also be put in the middle of the plot? It's what we see, in particular, with the geomagnetic are in the ancient writings that I am going to show next. So, is it the same to have the vine without an antenna or the vine with an antenna not? In fact, why? Because look, there we have the schematization of the lines of the tension lines. The tension lines are, what is it that, in fact, you have the atmosphere that is electrically charged. The atmosphere is electrically charged, that is to say, that if at ground level we have 0 volts, you see the ground is electrically charged negative, the air is electrically charged positive. If at the level of the ground we have 0 V, every meter starting, leaving, we will say, clearly, we have approximately 100 to 120 volts per meter in normal weather, which can change, in particular because there are storms that can rise a lot more, for example. So we realize that the higher we go, the more we go up to voltages that are high. If we take a base of 100 volts per meter, you see if I go up to 7 meters, I have 700 volts. And that's what also happens, is that with these voltage lines, which are normally straight if there is no, when there is an antenna, it will curve them, it will curve these voltage lines, and you have the negative of the ground who will go up to the top of the antenna. In brackets, when Christopher says that you have to climb a minimum of 6 meters 25 to 6 meters 50, we understand it here. Why? Because we will go up to higher voltages, and if those that will allow us to have a greater potential difference between the low of the antenna and the top. So now I think the antenna was set to 8 meters, and this will, therefore, allow us to have systems that interact with natural ambient electromagnetism. So we have the question, are there dangers with lightning? Well, I put antennae for about 10 years in my garden. I did not have lightning. In the ancient writings, I did not. He who had lightning accidents and received no feedback on this in the last 10 years. Now zero risk does not exist, so if you don't feel like it, don't do it. I do not recommend walking under the antenna in lightning weather, although it has happened to me to take measurements in stormy weather. However, I do not advise you to do so. There was someone who testified last time and said that if lightning strikes a table, the cable should go up carefully and crush, which would prevent burning the entire row of vines. We can always find these experiences in ancient writings and in modern times by people experimenting with this. What we observe is better productivity, resistance to diseases, and a qualitative taste when combining biodynamic techniques with respect for the soil. For example, the bigger the antenna is, the more massive it is, the farther it can distribute energy. The number of plots depends on each case, as there is no golden rule that applies everywhere. It is better to start small and experiment before expanding over the whole plot to find the best formula for your home. Flow crystals showed us an antenna connected on the geographical south side to have an additional magnetic interaction with the natural terrestrial magnetic field. We also find references to the geomagnetic field in old documents. When placed at the center of the plot, there are exchanges of electrons that stimulate the system. I started building a Megan last year, and my goal was not to make it big. I thought measuring the current flow between components would be more successful with a smaller structure. My antenna and the plot, as described in the old writings, were the focus of my measurements. I observed that between my antenna and the wire fence system buried in the ground, there was an average current of 71 milliamps. This current could reach up to 1 volt on average. The fluctuation in current occurred due to the charging and discharging process, particularly during storms, where it went beyond 71 milliamps. This fluctuation is influenced by the ambient electromagnetism. For your information, a group of LEDs in garden lighting systems typically operates at 4 volts. This demonstrates the presence of natural current, as I confirmed through my measurements. Therefore, it is not a trivial matter. During my visit to Belgium with Julian, he showed me their innovative market gardening system based on permaculture at Vineyards. As we toured the plot, I noticed their clever system for supporting bin plants on trellises made of iron rods. In the context of electroculture, adding an antenna to such metallic structures could potentially enhance their interaction with higher voltages, benefiting plants like beans or vines which naturally grow upwards. Plants like beans and vines naturally seek height, and by guiding them with structures, humans inadvertently prevent them from accessing aerial electricity. By incorporating simple antennas such as metal stakes made of copper with spikes at the top or wooden poles wrapped in copper wire with spikes, planted in the garden, we can explore numerous experimental possibilities. The methods for creating antennas are diverse, drawing inspiration from ancient writings and utilizing materials like copper, aluminum, or zinc connected to metal or wooden poles with a common wire. Electric copper, which is electroconductive, iron, which is ferromagnetic, and that's it, we have a choice. Depending on how we connect to our crop plot, there is not just one way. There is an unlimited way of doing things. In fact, what we are currently witnessing in the English-speaking world is a boom in electroculture. There are more and more people who are interested in this subject, and we are receiving increasing feedback from them. We hope that a similar trend will occur in France, leading to a boom in electroculture. Positive changes are already happening in this area, and we are working on expanding these developments. To conclude, I want to mention the super antenna of Alain de Harp de Divergence, who developed a highly advanced aerial antenna to demonstrate that antennas can become more complicated. He connected his antenna to water, which is a fascinating experiment he conducted. By watering his seedlings with this setup, he noticed atypical growth patterns. This illustrates the unlimited possibilities for experience, discovery, and sharing of information in electroculture. For more details, you can watch a video on this topic on the channel or permaculture.com. I have recently released a book on this subject, along with other complementary resources in airy and magnetic colors. Your support in sharing this knowledge freely is appreciated. You can contribute by acquiring the book. Thank you for your support. Additionally, there is the second energy tower made of basalt, which is magnetic, and a third one coming soon at the end of April. You can find more information on PERMAFUTUR.com to learn more about supporting my work and helping the further development of PERMAFUTUR. I have also created a Facebook group for sharing and exchanging ideas on electroculture. I recommend checking out the other linked videos for further information. Wishing you all the best and hoping for great things ahead. See you soon. Goodbye.